Good morning, everyone. Welcome back to math class. As I said last time, we're going to be jumping into the area of polygons this week. Now, because this takes a significant portion of chapter 6 to cover, what I've done is I've broken it down into 4 digestible parts. Part 1, today, we'll be covering area of rectangles, squares, and triangles. Now, before we actually go into any equations, we need to define what area is. Simply put, area is the amount of space taken up by a 2D shape. And we could see this with the rectangle on the screen. The blue region inside our polygon, our rectangle, is the area. Meanwhile, from last class, we learned that the green outline is the perimeter. It's very important that you don't confuse the two. They are completely different things. We can say that area is a two-dimensional measurement and perimeter is one-dimensional. What I mean by that is if you take your perimeter, if I take the height on this side, we clearly see that it has height but lacks any length. Meanwhile, over here, our line here has length but lacks any height. Our blue area has both height and length. And we could demonstrate this further with this orange line. So this again only has height, but if I drag it across the screen and have it leave a trail, we will have 2 dimensions. So here we go. We can clearly see now that it has height plus length. All right. So all shapes have their own specific equation to find area. We'll be looking at 2 equations today, and you can actually see the list of our equations in your workbook on page 231. So I highly suggest turning to that page when you do your homework. Example 1. What's the area of the rectangle and square below? So we have 2 different shapes here. One on the left is our rectangle and the one on the right is our square. Now recall from last class, a square is a regular quadrilateral, meaning each side is equal to each other. So all my sides of this square is 4.1 centimeters. So to find the area of my rectangle, all I have to do is multiply base times height. Now you might see base, you might see length, they are the same thing. So let's plug in our numbers into our equation here. So we have 6.2 centimeters times 2.9 centimeters, and because they're in the same units, right, we have the clear to multiply them. Had one of them been in millimeters and one in centimeters, we would have had to convert one of them. All right, so still be careful for that. Make sure that they are in the same units. When we multiply these 2 numbers, it gives us an area of 17.98 centimeters squared. Now that's very important to remember that because it's an area, we need to have our units in squared units. Remember, it is a 2-dimensional measurement, meaning it's squared. All right, moving on to the square. Our area is essentially the same, but we typically use the word side length. All right, and there's a good reason for that. You'll see in example 2. So let's fill in our equation here. 4.1 centimeters times 4.1 centimeters. We can write that, we can simplify that as 4.1 centimeters squared. And when we do that, we get an answer of 16.81 centimeters squared. All right, so again, it is area, so our unit has to be squared. And it's very, very important that because I'm working with 2 different shapes here, to make things really neat, please identify where to which shape your calculations belong to. So simply write it out and then do your calculations below it. It makes it a lot easier for us teachers. Example 2. What's the side length of the square below if it has an area of 102.01 centimeters squared? So this one we're going to be working backwards. We're given area, but we need to find the side length. All right, so what we have to do is write out our equation. Area is equal to side length times side length. I've shortened it here by just writing S. All right, and I've plugged in my area as well as squared my S, because S times S would give me S squared. Now, here's the trick. We want to know what S by itself is equal to, not S squared, S. So what we have to do is we need to cancel out this square. So how do you cancel out a square? Well, you take the square root. When you do that, these two cancel out and we're left with only s. And as I said last class, you are allowed to change the equation up as long as you balance it on the other side. So again, this equal sign is like a mirror. So if I took the square root of s squared here, I need to take the square root of my area. And when I do that, I square root this number and I lose the square on my centimeters. So I'm going into a one-dimensional measurement. And I'm left with 10.1 centimeters is equal to my side length. Example 3. What's the area of the triangles below? So I have two triangles. I have a right angle triangle and I have an equilateral triangle. For the right angle triangle, I'm going to use this equation. Area is equal to base times height divided by 2. Now you might notice that it looks very familiar to the equation used for a rectangle, except we're going to divide by 2. In our next slide, I'll show you where this division by 2 comes from. All right, so before we do all that, let's actually do our calculation. Let's plug in our numbers. So 6.1 centimeters is our base or length, whatever you want to call it, multiplied by my height of 3.5 centimeters. We're in the same units. We're allowed to move on. Multiply that, divide by 2, and we're left with an area of 10.675 centimeters squared. Now let's do the exact same thing for the equilateral triangle. Now because it's a different type of triangle does not make it different. We are still using the same equation, base times height divided by 2. The height, however, is inside, so don't be fooled. In the future, in Sec 3, you'll actually be given this part. That's called the slant height, but not the height. The height is always from the tip, one of the points, down to one of the sides, so it forms a right angle. All right, so let's plug in our numbers. 5.8 centimeters times 5.1 centimeters. They have the same units. We can multiply them. That gives us this, and then we divide by 2 to get 14.79 centimeters squared. Again, both our answers are in squared because area is a two-dimensional measurement. All right, so let's talk about why we divide by 2 to find the area of a triangle. To show this, let's take this rectangle, this very, very green rectangle. I can find the area by taking the height and my base or length and multiplying them. So 12 times 6 gives me 72 centimeters squared for area. Now, if I cut this rectangle so I have half of it left, what I'm going to do is I'm going to cut it this corner here, cut it all the way down to this corner. And what I'm going to be left with is a triangle, right? And you probably know where this is going. Since I cut it in 2, I divide by 2, and now my area is 36 centimeters squared. So this is where the equation comes from. All right, guys, so that's the end of today's lesson. Please make sure to go back onto the whiteboard so that you can do your knowledge check. And once you're done with that, you can join the Zoom call where you can ask me questions and we can take attendance. All right, everyone, I'll see you in a bit. Bye.